Alright, so usually when you've been graphing linear equations, all you need to do is find 2 points on the line and then connect the points, and that's your line. So for example, you might have something simple like y equals 2x. So you make your little chart to find a couple of points that are on this line defined by this equation. So you just kind of pick a couple values of x, maybe 0 and 1. You plug those values into your function. So you've got, for this first one, it's y is equal to 2 times 0, because x is 0 in this case. So it's going to be 0, and then y equals 2 times 1. Y equals 2 times 1, which is 2. So then you can plot those 2 points. 0, 0 would be there. And 1, 2, x is 1, y is 2 would be there. And then you could just connect them with a line like that. Put arrows on the end of your line to show that it goes on forever. And then you're done. Right? So all you really need to graph your typical linear equation is 2 points, right? Because a line connects 2 points. But this isn't going to work for an absolute value equation. And let me show you why. So let's just make this stuff go away, because we don't need that anymore. So absolute value is just distance from 0. So if you think of a number line is a great metaphor. Right, let me get my pen tool. Let's say you've got 0 here, and you've got 1 and 2 there, and you've got -1 and -2. How far away is 2 from 0? 2, 1, 2 units away. How far away is -2 from 0? 1, 2. It's also 2. So the absolute value of 2 and -2 is both 2, right? So that's the idea of absolute value, this distance from 0. So what that means as far as graphing absolute value equations is actually something weird happens. Absolute value equations look something like this, where there's a certain point at which the graph changes direction. And it's because of this negatives becoming positives type idea. So let me show you. So you can't just, okay, so let me show you. We're going to graph this absolute value equation. And I'll show you what happens. So let's just kind of do the way you would think, where you can just plug in a couple of points. So we're going to plug in 0 first. So I'm plugging in 0 for x. It's a 3. Let's see what I get for y. 0 minus 3 is -3. The absolute value of -3 is just 3. And then let's do the plus 2. So 3 plus 2 is 5. So if I plug in 0 into this equation, what I get is 5. If I plug in 1, what do I get? So I've got x is going to be 1 this time. So 1 minus 3 plus 2. So 1 minus 3 is -2. So the absolute value of -2 is 2. 2 plus 2 is 4. Alright, so I could just say, I'm going to plot my 2 points. 0, 5, x is 0, y is 5, 1, 2, 3, 4, 5. When x is 1, y is 4, so x1, y1, 2, 3, 4. And then connect my points, right, with a line. I'm gonna make a red saying, warning, this is not the real graph. Okay, well, check this out. I'm gonna plug in another x here. Let's say 5. What if I plug in 5 into this equation? So I've got 5 minus 3 plus 2. So 5 minus 3 is 2. So the absolute value of 2 is 2. 2 plus 2 is 4. I plug in 5, I get 4. So is that value, I need more of these guys. Let's plot that point, 5, 4. 1, 2, 3, 4, 5 is x. 1, 2, 3, 4 is y. That point's not on this line. What's going on? Well, what's going on is absolute value functions tend to have this shape, where the thing changes direction at a certain point, right? So just plugging in 2 points isn't going to work for absolute value functions. So let me erase this stuff, and I'll show you the real way of doing it. So I'm going to pause this and erase. All right, so we're ready to keep going. So here's how to graph absolute value equations. The key thing is you need to first find what I like to call the anchor point. That's this point at which the graph changes direction. You know, if these rays are going like that. It's the point suddenly at which, you know, it's been going like this for a while, and then boom, changes its mind and goes in a different direction. I call that the anchor point. More technically, that could be either the maximum or minimum. You know, if it's a function that's pointed downward like that, it would be a maximum. In this case, it's a minimum. Okay, well, I call it the anchor point. You can kind of think of it as the point from which the two sides are shooting off into space. I don't know. That's the way I think about it. Okay, so you need to find that first. Okay. So the way you find that is you look at the absolute value part of the equation. The stuff that's inside of the absolute value function itself, you know, between the two bars. And you find the point at which that stuff inside will equal 0. So find the value for x when that thing inside is equal to 0. Okay, so I just set so this is gonna be number 1 here. X minus 3 equals 0. Okay, so I could solve that. Plus 3. Add 3 to both sides. So x equals 3. So when x is 3, this thing inside the absolute value bars will be 0. And that's the point at which the graph changes direction. So the x coordinate of our anchor point is 3. Now, if there's something, if there's a plus something or a minus something, that shows how far up or far down it shifts. So usually, okay, if this plus 2 weren't there, the anchor point would be at x equals 3. So it would be here, 1, 2, 3. That's where it would be. But because there's a plus 2, I'm just going to shift it up 2. If it were negative 2 out here, I would shift it down 2. Okay? That's all that's happening. This is a vertical shift, either up or down. All right? Now, so we found, okay, so in this case, our anchor point is at 3, 1, 2, 3, 2. It's shifted up 2. So that's step 1, finding the anchor point, 2. All right. So now we can do the old plug in the value type thing, but I'm going to pick a value for x that's to the left of the anchor and to the right. So let's choose a value of x that's to the left. How about 1? Oh, x equals 1. All right. And now let's plug in 1 to the right. Let's see. So if this is 3, 4, 5, we'll plug in 5. Actually, no. Let's plug in 7, just for fun. Okay. So let's plug in those values of x into our equation and see what we get for y. So this first one, I'm going to say y equals the absolute value of x minus 3, but x is going to be 1, so 1 minus 3, and then plus 2. So do the stuff inside of the absolute value first. So 1 minus 3 is negative 2. The absolute value of negative 2 is 2, and then we have our plus 2. So 2 plus 2 is 4. So y will equal 4 when x is 1. try our second x value. Now this is to the right of our anchor point. Y is equal to 7 minus 3 plus 2. 7 minus 3 is 4. Absolute value of 4 is 4 plus 2 is 6. 6. So we've got a point to the left and a point to the right of our anchor point. So let's plot those points. So point 1, 4, x is 1, y is 4, 1, 2, 3, 4. X is 7. When x is 7, y is 6. So this is 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. It's 1, 2, 3, 4, 5, 6, 7. Yeah, 1, 2, 3, 4, 5, 6. Okay, double checking. Now we start with the anchor point, and we connect it to the point to the left. Make this green. That didn't quite line up with my points. There we go. It's not. You can probably do this better on your piece of paper. My points are too big. That's the problem. Kind of looks silly. Okay. All right. Just need to, okay, something like that. And then I take my anchor point and I connect it to the point to the right. Let's make that green. And let's see. Just want to line it up with the middle of that point there. Okay. So that's all there is to it. Now I've got my absolute value function. It goes, these arrows say that it keeps going off forever in that direction. It keeps going off forever in that direction. But here's the point at which it changes direction. All right, so that's graphing an absolute value function. Find your anchor point first, and then plug in a value to the left, plug in a value to the right, see what you get. Find your coordinate pairs, plot the points, and then start with anchor, connect it to the point to the left, connect it to the point to the right. You're done.